This problem is an example of a mixture problem, and we can solve this mixture problem with a system of equations, but we can also solve this in a little bit different way using proportions. So I'm going to show you how to do this with using a system of equations first. So we have two acids, and we want to make a new acid solution. So one acid solution is 40%, the other acid solution is 80%. And you need to mix these to make a 60% acid solution. Okay, so to do this, well, if we're starting with 40 and 80, we know we need 60 is going to be exactly in the middle, so we need half and half. Okay, so we'll set this up as a system, and we should get 200 milliliters of 40% acid and 80% milliliter. 200 milliliters of 80%, so 200 of each. So we're going to let our variables, okay, so it says how much of each do we need. So we're going to let X equal the volume or milliliters of 40% acid, and we'll let Y equal the milliliters of 80% acid. Okay? And we know that X plus Y, the two volumes, must add up to 400. So there's one relationship. And the second relationship is going to look like this. And there's a few different ways we can set this up. So we can work this out as a 60% acid calculation. But I'm going to do this slightly differently. And it's a little bit easier to do this way because we have an easier equation to work with. I'm just going to work out the amount of acid. So my equation is going to be for amount of acid. So this equation is for the volume. This equation is going to be for the amount of acid. Okay, so I don't want to work with a percentage. I'm just going to work with the actual amount of acid. So the total amount of acid is going to be 400 milliliters at 60%. So we're going to multiply that by 0.6. Okay, so there's my 60%. So that's going to represent the total amount of acid. And the total amount of acid comes from partly from 40% and partly from 80%. So the volume at 40% times 40% gives us the amount of acid from that solution. And the volume of acid at 80% times 80% gives us the total amount of acid from the 80%. Okay, so these are my two relationships. This represents the volume. This represents the total amount of acid that I calculate. So the amount of acid here, which I'll rewrite, is going to be 240 milliliters of pure acid, and that's going to be from 0.4x plus 0.8y. So I'm going to solve the system now. I have my two equations, so I'm going to let y equal 400 minus x and do a substitution. So I'm going to substitute 1 into 2. Okay, remember we can't substitute. We have to, if we start with 1, we have to substitute into 2. So I get 240 is equal to 0.4x plus 0.8 times y, which is 400 minus x. Okay, I'm going to then multiply this out and solve for x and y. So we end up with 0.4x plus 320 milliliters of acid times 0.8x. So minus 0.8x. So combining like terms here, I get negative 80 on this side. I'm going to get negative 0.4x on this side. Okay, x 80 divided by 0.4 is going to give me 200. Okay, so I have 200 milliliters of X, which is what I expected, and we also then get 200 milliliters of Y. Okay, this is what we expected because we wanted to make 60% from 40 and 80, we want half and half, or 200 and 200. Okay, so that makes perfect sense. Okay, so we can use the same strategy to solve the other one. Okay, so I'll do the same thing here, but now this is slightly different because we want to make a 50% acid solution. So that means we need a little bit more of the 40% compared to the 80%. But we're going to set it up the same way. So we're going to let X and Y be the same thing. So the volume of 40% solution and Y equals the volume of 80% solution. Okay, and then we're going to come up with our equation. X plus Y equals 300. Our second equation is going to be X times 0.4 plus Y times 0.8. And this time it's not going to be equal to the 60%, so it's going to be 300 milliliters times the 50% or 0.5. So it's going to be the total acid from X, the total acid from Y, gives us a total acid of about 150 milliliters. So I'm going to rewrite that equation. 0.4X plus 0.8Y is equal to 150 milliliters of acid. So this is a total acid. This is a total volume. So I'm going to take equation 1 and do the same thing. I'm going to do Y equals 300 minus X. And again, I should expect to have more of the 40% because we're closer to 50. The 50 is closer to 40% than 80%. Okay, so I'm going to solve for equation 1. And then I'm going to substitute into equation number 2. Okay, so once I've done that, I'm going to solve this equation. So 0.4x plus 240 milliliters of acid minus 0.8x equals 150 milliliters of acid. So in this case, I'm going to move the constants to this side. So I'm going to subtract 150 from both sides. I end up with negative 0.4 on this side, so I'm just going to add 0.4 to both sides to get 0.4x. Okay, and then if I divide these, I get 90 divided by 0.4. That's going to be a repeating decimal if I'm not mistaken. So this is not a nice number, so it's going to be 90 divided by 0.4. No, that's okay. It's going to be 225 milliliters of the 40%, and that makes Y equal to 300 minus the 225, which is 75 milliliters of the 80%. Okay, so this is kind of what we expected because X is the 40% and we wanted more 40% acid when we mix it with the 80% because we want it to be 50%, which is closer to 40 than it is to 80. Okay, so we wanted less 80, more 40%. Okay, and that's what we ended up getting here.